Hello everyone and welcome to .NET Core Central. In today's video, I'm going to walk through microservices theories, meaning I'm going to go through what I have learned so far building microservices. Now this video is going to be a little bit different than rest of my videos, meaning in these videos, I'm not going to go through any code, and this is due to interest of time. In this video, I'm just going to go through the theories of microservices. Now to start with, let me explain what is that I'm going to cover in this video. Now in this video, I'm going to walk through what is microservices from my experience. It is completely based on my experience at work and what worked for me over the last 3 years of using and building microservices. Now, one thing I want to make clear, the concepts and the theories that I'm going to discuss here are going to be a little bit different than what are the videos you see out there. I'm going to define microservices based on what worked for me, and it might not be in line with some of the videos out there, meaning there are videos which talks about building microservices based on domain-driven design, how to create domain, how to create bounding context and things like that. I take microservices based on what is the need. So before we go into microservices, first let's understand why we are here, meaning why there is so much hype about microservices and why we need it. In my opinion, all of this came with the need to be agile and meet market need at a faster pace. And I cannot think that we can separate agility from microservices when it comes to software development. As I go through the slides, it will be much more clearer what I mean by that. Before we get to microservices, it is very important to understand what we have been doing so far, meaning what is a monolithic application. Because even most of my career, I have been building applications which are monolithic. Some of them are really big, some of them are small, but in an essence, most of them were monolithic in nature. Now, what is a monolithic application? A monolithic application is an application where every part of the product is part of a single service or a web application. And usually the data of the entire application is in a single data store or a single database. And I'm sure you'd agree with me, in some of our applications, our databases end up becoming huge giant themselves and having tens to hundreds of tables in them. Not every application will have hundreds of tables, but yes, there are applications out there which have hundreds of tables in them. Now, what is the issue with monolithic application? First issue is source code management in source control. Essentially, it's a merge nightmare. Given that most of cases, again, there are exceptions to it, but in most of cases, I have seen one C# solution with multiple projects under them, and they have almost all code. The code definitely have some segregation, meaning you will see that there are business layer, there's data access layer, there are like utility classes and things like that, but everything under the umbrella of a single solution, which make it really tough for developers to manage the code. Though you can break components up as NuGet packages, but it is not always done. The second issue with monolithic application is you need a bigger team to manage bigger application. That's how it is. Now there are ways to solve it, and I have seen in bigger organizations there are horizontal team, but horizontal team has their own issues. It is even harder to move in a horizontal organization. The organizations literally move like sloth due to so much of interdependency. And third, and the most important aspect, and this is what drives me building microservices, is the code and database deployments as well as the rollbacks are usually nightmare when you deal with bigger applications. There are side effects of that. We end up doing lesser and lesser deployments because it's complex, and due to that, we lose agility. So as I mentioned earlier, everything comes down to agility. How agile you want to be, or what is the need of your business to be agile. That's what gave birth to microservices. Now, what is microservices? Microservices are nothing but smaller single responsibility services. Meaning, microservices does one thing and one thing only, and it does that thing good. And they have very clear boundaries. Usually, microservices own their data and the data store. Now, I say usually, There is a reason for that, and we'll get into the detail later. But in an ideal world, every microservice should own their data store. And the most important aspect of microservice is that the logic as well as the data of the microservice should not leak outside of it. That is a very important factor we have to keep in mind. Now let us consider a traditional e-commerce website. Even I am guilty of it. There are times when I built a web application where I have a single ASP.NET website and then a single database. Though in the ASP.NET website, I would have business layer, data access layer, and then services layer, and then website, but all of them are part of the same C# solution. And everything is very tightly coupled in that situation. Now, all the inefficiencies which comes with those monolithic applications are usually there. Right? I already discussed those. Now, if we have to take the example of this e-commerce website, how can we break this into multiple microservices? Now, what we can do is we can consider product as a single responsibility service, and everything that is needed for product is done by this service. And the product service owns its data store, meaning the database is part of the product service itself. Similarly, we can have inventory service, which deals with only inventory, user service, which deals only with users, and order service, which deals with only orders. Of course, there will be other services, but these are the 4 things I'm considering right now. Now here, the important thing to remember is that when inventory service had to look into product, it is not going to go into the product database directly. It is going to call upon the product web service or product API to get the information of the product. And this is the most critical part. The data structure and the internal logic of a microservice should not be leaking outside. Everything should happen through contract and through public contract only. Now, of course, here is the most important question. What about the cost of deployment, right? Now we have one single monolithic service, single SQL server. We are paying the cost of a single database server as well as licenses. Now, if you go out of SQL Server and use open source database like Postgres, the cost equation gets a little bit different. Still, you have to worry about multiple boxes. And with IaaS, there is obviously the other cost we have to worry about. So the main issue with IaaS is, or the main cost factor with IaaS is, if all services are deployed in the same Windows machine inside of an IaaS under different virtual directory, the issue is if the IaaS fails, the entire app fails. Meaning, if the IaaS crashes due to a bug or a problem inside of the order service, the user cannot even log into your website, which is a very bad user experience. Now, at the same time, if you want multiple IaaS and boxes so that you can have proper separation and isolation, there is, of course, significant cost involved with it. And with database, we have the same issue. We have to have different databases, and especially if we are talking about SQL Server, the server cost as well as the licensing cost will significantly increase because it is important to have database isolation. Having all the database in same database server is also not an ideal solution. Now, what is the solution that we have? Well, we have containers, and that's the solution for us, right? Now, what is containers? Containers are used for packaging software and all its dependencies into a standard unit of development, deployment, and shipment. Meaning everything that is needed for developing, deploying, as well as shipping a software is encapsulated inside a single unit. And that's the unit which is deployed into multiple environments. And they are immutable. Meaning you can take the same image, run in 5 different places, they will behave the same. And that's the most critical thing about containers, and that's why they are so successful today. Containers are defined as images, which essentially becomes containers on runtime. So you define them as image, but when you execute, it becomes the runtime itself inside of a server. And Docker is arguably the most popular container implementation out there. There are a few others, but I think Docker is the de facto which everyone uses. Now you might be asking, well, we had virtual machines. They also give similar isolation. Then why not use virtual machine? Why container is so important? Well, there are multiple factors for that. And let's go, what are they? So containers are usually extremely lightweight, and their sizes most of the time are in MBs, whereas virtual machines are heavy and they can go up to gigabytes of size. The second, and this is the most important part I think you would need to have when you are building microservices, is start time. Containers are really fast to start. They are usually from seconds to minutes. That's about it. That's the start time. And by minutes, I'm meaning single digit minutes. Whereas when it comes to virtual machine, they take 15 to 30 minutes based on what you are dealing with. And that's not ideal when you want to scale out your application based on load. And the question is then you might ask, well, I can keep all the things based on my peak load. Yeah, you can do that, but that is not cost effective. The cost effective way to do it is to scale things out as and when it needed. And for scaling things out on demand, you need things to be scaled out faster, right? You cannot afford to lose your customers because you could not scale out. So that's one very critical point. The third thing is containers, of course, are best suited for microservice. Virtual machine can be used for microservice, but they are not cost effective, as I just mentioned earlier. The next point is resource utilization can be optimized to use the most out of the machine. And this is something I have been seeing day in and day out, where we use our Linux boxes to the maximum capacity with microservices. Some of our boxes run 20 to 30 microservices at a time. And that's amazing, which is almost impossible to see it in virtual machines if you're just running on virtual machines. The CPU and memory usage are usually extremely low. But there is one thing which is better in virtual machine, which is essentially security. But in terms of security, I'm talking about security across containers. VM gives much better security. But if you are managing the box yourself and all containers are your own application, you don't have to worry too much about that. But this is something to keep in mind. There are solutions for that. There are concepts of using hypervisor to solve it. I have never done it, but I know there are solutions out there. If someone needs, they can do that. The next question is, how is container helping me as a .NET developer? The good news is .NET Core application can run on containers. In fact, .NET Core was built with container in mind. It was built to be working with Docker. If you look into the initial days of .NET Core, the very first example I would say I worked on was using a Docker container. The next thing is running container gives all the advantages of container, which I just discussed earlier, including saving of cost and efficiency. And Linux is my operating system of choice because it is usually much cheaper compared to a Windows box to rent out in a cloud of your choice. And I have seen performance of .NET Core application in certain cases are 5 to 6 times faster than a standard .NET application. So that's something to keep in mind. The next point is databases like Postgres can easily run in container and have isolation we want. Meaning the first point that I mentioned, that the microservice owning its database, I think it's easier to do with containers because you can run your Postgres database into a container and you can get all the advantages. Of course, there are things which we need to worry about, which are saving the actual data, because containers are immutable. They come up and go down. They doesn't maintain state. So how you persist your data is something you have to worry about, and you have to take care of that. But there are solutions out there to do it. Now, next question you might have is, okay, I understand all this. When should I use microservice? Now, that's a very subjective question, and it depends on your style of design and your style of architecture and what you want to do. But these are few things that I usually follow. I would say if you are not sure, start with a monolithic application. Start with everything in one place, and then as and when the application grows, figure out what makes sense carving out into different location. Again, keep in mind the fundamental principle of why you want to go to microservice. If it is agility, then what makes sense moving out so that your deployment becomes easier. Most important thing to agility is how easy it's to test and deploy your application. And that's why microservices are becoming popular, because it's easier to test as well as deploy microservices. It's cheaper to test microservice because you are just testing part of an application, not the whole one. And of course, the deployment is faster because you can just throw in a Docker image and move something there. Now, another question Or another doubt you might have is, well, if I have a .NET Core application, I can still build the entire thing inside one .NET Core application drop as part of a single Docker image. Is not that a microservice then? The answer is no. And why it is no? Well, as much as your deployment can be faster, you still have the other problems, which is what is the number of your team? How many people are working in your team? How do you manage the team? How do you manage releasing the features? Everything is inside one application. There are challenges with that. Apart from that, there are challenges in terms of testing. Because you are changing a unit of code, the entire workflow needs to be tested. So what decides when to go to microservice? In my opinion, as I mentioned, the main deciding factor is your agility for deployment. Think about which functionality makes sense breaking up for ease of deployment. And ease of deployment means if a feature request comes in, you should be able to implement the feature and deploy within a couple of weeks' time. That's what I mean by agility. And if you're going with microservices, Docker is your best friend, because your deployment will become so much more easier. Same is with testing. It's never going to be, oh, well, I have a problem in production and I'm not able to reproduce because the servers are different, the environments are different. That's never the case with Docker. The images are same across environment. Next question might be, what are the tools needed? Well, technically, you don't need any tool for building microservices. You just need a .NET Core application and the fundamentals of building microservices and deploying them. But of course, things are there to help. As I mentioned, Docker is your best friend. It helps you deploying microservices much more easier. When you use Docker, there comes the question on how to scale out or scale down. Hence, we need orchestration engine. Kubernetes is the most popular and open source container orchestration engine. But in my opinion, when you start, you don't need an orchestration engine. It's only when you go into managing 50 or hundreds of microservices, yes, you need to worry about orchestration engine. But initially, when you start, you don't need an orchestration engine. You can go with static loads, static number of containers, and if you're using cloud provider, most of them provide ways to handle those. I use AWS, and the ECS service which is provided by AWS is good enough to start with microservices before you go full throttle. Now, next important thing I want to discuss about is microservice communication, meaning how microservices talk with each other. The most popular is the REST API, and it's because it's easy to build REST APIs. We have been using and testing it for a long time now. Once you define the contract, it's very easy to communicate. gRPC is catching up quickly, and I can see myself using gRPC for most of the service to service communication inside of my data center. But for external, I'll still go with REST API. The next important pattern is message based communication, and I use it in a lot of places. It has a lot of advantages, of course. Now, for message-based communication, whether you are using a queue or a PubSub, it works well for offloading work to some background microservices where response is not time sensitive. For example, bank statement for last 1 year. When you are into your banking application, your expectation usually is not to get the statement right away. You're going to worry about getting statement right away for your current month bill. But what happened 1 year ago, it's usually when you are filing your taxes. So time is not that sensitive at that point in time. So those cases, you can offload your work in a microservice through a PubSub or a queue. And then of course you can get back response through another queue. And those are really, really useful pattern if you want to decouple things completely. Using REST, you are still coupled with a service, and there are implications using REST API, which I'm going to talk later. With message-based communication, you get a lot more flexibility in terms of decoupling. The next important question would be, how do I convert my monolith into microservice? That's the most important question in my mind. And that's what I also have been asking when I initially started. And then what I found out playing around and converting my applications into microservices, number one is bring out the most easily separable component from your monolith first. Don't try to do everything together. Take one step at a time. See which component is most isolated and can be easily brought out. For example, authentication and authorization doesn't have to be part of your application, can be given to a third-party authentication service. The next thing is if you have some sort of user management component that can be moved out. Again, it depends on application to application, but you separate what is the easiest one out of your monolith. Now here, if you are using SQL Server or something like Oracle, your first option might be to make service responsible for table set instead of entire database. And this is something I'm talking purely from my experience. It is sometimes harder to go and ask for 3 more SQL servers because there are costs associated to it. And if you want to go out of SQL Server to something much more cheaper like Postgres, there's a lot of work associated with it, which might not be justified initially. So what you can do is, first you can start with isolating the tables, meaning all the tables are in same database, but you ensure that for a set of table, a single microservice is responsible for that. And any other part of the application which wants to read the data from this table goes through the microservice instead of directly connecting to the table. That is your best bet to start. And then when you have done this table set segregations and every microservice is accessing their own table set, it is astronomically easier to move things out into their own databases. If you are using any of the cloud provider, go with managed databases like DynamoDB in AWS or Cosmos DB in Azure. Those are easy to start up, easy to put data in. There are some pluses and minuses, of course. If you are dealing with multiple tables and you want to keep relationship, then some of these database might not work. In that case, you can still go with managed Postgres, which in terms of cost is really cheaper compared to a SQL Server due to licensing. The next question might be, well, I segregated all my data into different database. What about reports? Or what about if I want to get a view of all the data together in one place? So there are a couple of ways to do it. One is you can use an aggregator service, or you can write some sort of aggregation if you have API gateway. I have a video on API gateway which I did on my last week. I'm going to share the link above. You can take a look into it. But API gateways support data aggregation. Though in my video I have not spoken about it, but most of the API gateway, including the one I am using, which is Ocelot, supports aggregation. So you can use either API gateway or an aggregator service to get data from multiple services, aggregate them, and throw it to the user. The other option is you can create a data stream for all the data and have an aggregator create a read-only view of the data. In my opinion, the data stream option is much more elegant and gives you much more options in how you want to show the data. Now, if I want to show that from the 4 microservices that I created, so I have the product, I have the inventory, user, and order. Now, whenever a data change happens, those information can get into a data stream. For example, the product can send any change, whether it's add, update, or delete of products, into the data stream. Same thing for inventory, user, as well as order. And on the other side, you can have a reports microservice which is reading data from the data stream, and then it is aggregating the data or doing whatever is the need for your data visualization and putting that into a read-only database. Now, few important notes from my experience. Number 1 is, when you start building your microservice, think about resilience during design. Don't make it as an afterthought. In my previous example, when you are making a call from inventory to product, if the product service fails, how your inventory service is going to react. Make sure you have proper resilience, because the whole point of building microservices is that if one part of your system is down, the entire application should not be down. So thinking about resilience during design is extremely important. And I have done a couple of videos on building resilient microservices using Poly. You can take a look into that. There are a bunch of other information out there in internet on how to build resilient microservices. You should be able to find those. Second thing, establish a communication pattern you have to use between your microservices based on response need. Meaning, what is the time you want to go with REST and HTTP? What is the time you want to use gRPC? Versus what is the time when using queues and PubSub makes sense for you? Those has to happen during architecture and design phase. Logging and monitoring cannot be an afterthought. Logging and monitoring is probably the most critical aspect of building microservices. It's much more easier to debug a single application or a single monolith compared to a distributed set of microservices. The only thing which can help you is good logging. A cloud-based centralized logging is extremely critical. Also, passing a correlation ID across microservices would save you a lot of debugging time in future. This is another critical aspect you have to keep in mind. There are different ways to do it. You can use header to do it. If you are doing message-based, messages can have header. HTTP can have header, gRPC can have header. So you can always create a correlation ID at the beginning or the starting point of your request and then pass it along to all the component so that the correlation ID is logged. And this can be completely done by a logging handler. Your code doesn't even have to know about it. Another thing which I learned the hard way, don't build a distributed monolith. Meaning keep the services completely decoupled from each other. One service should not know the internals of another service, should not depend on the internal of another service. The contract should be extremely clear and they should be extremely easy to integrate with. Build your microservice as if it is built for external user and not for your internal services. That's the only way to make sure that you have solid API design. Now in this video, I just scratched the surface of what microservices is. There are a lot of things into it and you might have a lot of questions. Please put down all your questions in the comment and I will try to respond as much as I can. Thank you so much for watching this video. And if you like this video, please give me a thumbs up. And if you are not subscribed to my channel and you think you will get value out of my channel, please subscribe to it. Thank you so much.